So section 3.2 is quadratics. There are a few questions at the beginning that involve solving quadratics using either graphing or the quadratic formula. We did those in module 1, so I'm not going to redo them, especially when the majority of this homework assignment is on graphing. So I want to spend some time focused on that, okay? So the vertex of a quadratic is its turning point. So for this quadratic, that is the vertex. It would be at -1, -4. And so the vertex is also a local either minimum or maximum. You can look at this one and see that it's a minimum. So it's a local min of, we would say, -4 at, not q, yes, q equals 1, -1. So remember we said this is your minimum and this is where it's at. So is the y and the x. Every quadratic has a domain of all real numbers. Domain of a quadratic is always all real numbers. Now, the range of a quadratic depends on a few things. It depends on where the vertex is, and it depends on whether it opens up or down. So here the vertex has a y value of -4, and the quadratic opens up from there. So my range would be -4 to infinity. If it opened down, then it would have been -infinity to -4. The w-intercepts are the places where it crosses the w-axis or the x-axis. And so that would be here and here. So we have w-intercepts at -3 and 1. The q of w-intercept is here at -3. So that would be 0, -3. On what interval is q increasing? Well, it looks like it's increasing on this side of the vertex. So I'm going to say from -1 to infinity, because remember, when we're dealing with increasing and decreasing, we only want the x values right here. Okay. On what interval is q decreasing? So that's going to be this side. So from -infinity to -1. And now for right and left-hand end behavior, we've gone through this a couple times. I just want to fill in these first couple blanks. So as w approaches infinity, q of w, as w approaches -infinity, q of w. Because remember, for right-hand end behavior, it's always these three first. For left-hand end behavior, it's always these three first. Okay, so let's look at what's happening on the right. On the right, it's going up. On the left, it's also going up. So both of these would be that it goes to positive infinity. Okay. All right. So I wonder if they want vertex form or standard form. All right, well, we can start in vertex form. Here, my vertex is at 1, 2. And vertex form of a quadratic, this would be, is k of w where this is h and k. So here's what I know. -1 squared plus 2. The only thing I need to figure out is what is this a value. So this parabola has clearly been widened. I know because normally it would have gone through right here and then right there. My ratios here are that from my vertex, I go out 1, up 1 in each direction, out in each direction, and then up 1. And then from my vertex, I go out 2, up 4 in each direction, out 2, up 4. So this would have been a standard quadratic. Now, here, we see that when we went out 2, we only went up 1. So normally we go out 2, up 4. But instead, we only went up 1. So my question is, what do I multiply this that I should have gone up 4? I only went up 1. What do I multiply that 4 by to make it a 1? It's 1/4. And so that's one way to figure out what your A value is. Now, if that way doesn't work for you, you have another option. You can take this point, 3, 3, and plug it in for X and Y and solve for A. So let's say I couldn't, I don't know, those transformation rules, I don't know them. So then you put in your vertex, and then right here you would say, okay, I know the point 3, 3. So Y is 3 when X is 3. 2. Why did I write a 1? 3 minus 1 is 2. Squared is 4. Subtract the 2. Divide by the 4. So you have two options on how you can figure out what your A value is here. You can either use your transformation rules if you're comfortable with those. And if you're not comfortable with your transformation rules, then essentially we're doing the same thing here that we did when we were looking for B on the linear functions. Get a point, any point, plug it in, any point except the vertex, because this is the vertex, right? -1, 2, or 1, 2, I mean. Any point besides the vertex, plug it in and solve for A. So I could have also used this point right here, -1, 3, and I would have gotten the same A as 1/4. Okay? So this is my final answer. Okay. So if we're graphing from standard form, there's a couple different ways you can do this. I would say start at the vertex. So the axis of symmetry is x equals -b over 2a. And that is also the x value of your vertex. So here that's going to be -8 over 2 times 4, -8 over 8, -1. Oops. So my axis of symmetry is x equals -1. That is the x value of my vertex. To find the y value of your vertex, take that -1 and plug it in. -1 squared is 1 times 4 is 4, -8, plus 3. -4, plus 3, -1. So my vertex is at -1, -1. And then from there, you can use your ratios. We know we go out 1, up 1 normally. But if this is a 4, then you go out 1, up 4. And there's your quadratic. Now, that was a lot of work. I feel like more work than was necessary because you have this calculator, you paid a lot of money for it. You could always just have done this. 4x squared, 8x, 3. Oops, my window's off. Okay, if your window is off, zoom 6. No, zoom 6. There we go. Much better. And your more is going to require 2 points. Get out of here, buddy. More is going to require 2 points. It's going to require the vertex and any one other point. And you can get those from the table. Uh-oh, I turned my table off. Go to second and then window to get to table set. Put the independent back on auto. Go to the table. Why am my table starting at -25? I don't know. I'll have to fix that. So you'll know that you're at the vertex because your points are symmetric around the vertex. So you see how your y values are all symmetric around that -1. So that's your vertex. So you would need the -1, -1, and then any other point on here to be able to draw your parabola in more. Okay. All right. Okay. 2c squared minus 11c minus 21. All right, let's find the vertex the same way we just did. So we start with x equals -b over 2a. So that's a -11, positive 11, over 2 times 2, -11 over 4, or positive 11, excuse me, over 4, which is, I mean, we could really just leave it 11 over 4, honestly. And then to get the y value, we plug this in. So y equals 2 times 11/4 squared minus 11, minus 11 times 11/4 minus 21. 2 times 11/4 squared, 11 times 11/4 minus 21, -289 over 8. So then, since a is positive, I know this parabola opens up, and if it opens up, then that is a local minimum of your y value at c equals your x value. So in interval notation, your domain is always all real numbers. Since this opens up, your range starts here and goes up forever. Had a been negative, your range would have been -infinity until this y value. So you would have started at -infinity and stopped at this y value. Okay. To find the x-intercepts, you make y equals 0. So to find the x-intercepts, I'm going to put this up here. 0 equals 2c squared minus 11c minus 21. So I got to solve this. So let's see if we can factor. 2 times a -21 is a -42. Two numbers that multiply to -42 and add to -11. 42, 2 and 21, 14. What am I doing? 3 and 14. There we go. Okay, so it'd be -14 and a +3 minus 14c plus 3c minus 21. GCF out, 2c, c minus 7. GCF out. GCF out of c minus 7. 2c minus 3, or 2c plus 3. Set each one of these equal to 0. Then your intercepts would be c equals 7 and c equals negative 3/2. So for my k of c intercept, I make x 0. So that would be k of 0 is 2 times 0 squared minus 11 times 0 minus 21. But this cancels and this cancels. They both go to 0. So that is my y-intercept. A parabola that opens up is increasing to the right of its vertex. It's shaped like this. So a parabola that opens up is increasing to the right of its vertex. So we would say from the vertex and to the right. A parabola that opens up is decreasing on the left, excuse me, on the left side of its vertex. So this would be from negative infinity until 11/4. Can you guys give me 1 second? Okay. So then if this is the shape of my parabola, the right-hand end behavior is that as c approaches infinity, k of c also approaches infinity. As it goes to the right, it goes up. As c approaches negative infinity, k of c also goes up. So as it goes left, it goes up. As it goes right, it goes up. Now, my only regret about this homework assignment is that both of the ones we did were increasing. So keep in mind that if your a value was negative, had we had one with a negative a value, here are the things that would have changed. Your range would have flipped over. Your increasing and decreasing would have flipped over. So a parabola that has a negative a value is increasing on the left side and decreasing on the right side of the vertex. And your end behavior would both be negative infinity. Okay? All right. So the height in meters above sea level of a NASA launched rocket is h of t equals negative 49t squared plus 298t plus 108. What do we want? How many seconds until it splashes down? So if this is its height, then splashdown would occur at a height of 0. So in order to figure out when splashdown will occur, I'm going to make the height 0. And then I'm going to use the quadratic formula on this one. Negative 4.9, 298, 108. So t is negative 298 plus or minus the square root of 298 squared minus 4 times negative 4.9 times 108 or 2 times negative 4.9 negative 298 plus or minus squared 4 times negative 4.9 108 and then the square root of that 301 point, how many decimal points do you need? 301.531. Why did I write that all the way over there? That was weird. Over, that's going to be a negative 9.8. So then, negative 298 plus 301.531 over negative 9.8. One. A negative 0.36 seconds. I'm going to say no. Can't have a negative time. Negative 298 minus 301.531 over negative 0.98. So that same thing, only with a minus in between. 61, there we go. 61.177 seconds. So that's going to be my answer to part A. How many meters above sea level does the rocket meet its peak? Okay, so that sounds like if they're asking me for its maximum height. So anytime you're asked for the maximum, you're always looking for the vertex. So first we find the x. So the x value of the vertex is negative b over 2a. Negative 298 over 2 times negative 4.9. So that's going to be negative 298 over negative 9.8. 30.408 seconds. So it takes 30.408 seconds for it to reach its maximum height. To figure out what its maximum height is, we take this 30.408 and we plug it in. Negative 4.9 is 30.408 squared plus 298 negative, nope, 30.408 plus 108. So then my y value here would be 4638.816. That would be its maximum height. So this is the time at which it reaches its maximum height, and this is its maximum height. If we assume the rocket is launched from a launch pad, how high is the launch pad? So if the rocket is launched from the launch pad, that would be when your time is 0. And if time is 0, then your initial height is 108. So that must be the height of the launch pad. Okay. So another reason why I didn't do any questions dedicated to the quadratic formula and to factoring is because I wound up reviewing them both anyway. I hope that was helpful. And then last but not least, table below shows H. So here we're going to use our calculator again for regression, just like we just did, I think, last week or the week before, I can't remember. But this time we're going to do a quadratic regression. So we're going to start the same way as we did when we did linear regression. Go to Stat, and then press Enter for Edit. And we're going to put T into L1 and H of T into L2. 1.5, 1, 1.5, 2, 2.5, 3. 5, 7, 9. Okay. So again, X is in L1, Y is in L2. There we go. So to get our quadratic regression, we're going to press Stat, and then Calc, and then number 5 says Quad Reg, so that's the one we want, quadratic regression. All this stuff is okay. Calculate. So here they give me A, B, and C. So then my quadratic regression would be negative 4.9. What do they give me? So H of T, negative 4.9 T squared plus 26.4 T plus 55. Okay, that's how that works. Now, using this quadratic regression, how high will the object be 2.8 seconds after it's thrown? So that means T equals 2.8. I'm just going to plug that in, make it so that there's no I feel like the glare is weird right now. So, negative 4.9, 2.8 squared, 26.4, 2.8, 55. So at time equals 2.8, your height is 4027.184. And then use your quadratic regression. How long will it take for the object to reach 5 meters? So that's a height of 5 meters. So we're going to plug in 5 here. 5 equals negative 4.9 T squared plus 26.4 T plus 55. So if I subtract the 5 from each side, negative 4.9 T squared plus 26.4 T plus 50. So T equals a negative 26.4 plus or minus the square root of 26.4 squared minus 4 times negative 4.9 times 50 over 2 times negative 4.9. Negative 26.4. Oh no, I don't want to do that. I want to do this. So 26.4 squared minus 4 times a negative 4.9 times 50. And then we square root it. 40.951. And then we split it. Let's do left and right. Negative time again. I'm going to go with no on that one because you can't really have a negative time unless you guys have some kind of like cool spaceship that you're not telling me about. Or, I guess, time machine, actually. There it is. So it'll take 6.873 seconds for the, what is this? Object to reach 5 meters. Okay. All right.